Hi all. Today we'll be looking at the longest palindromic substring algorithm. It is number 5 on lead code. Hopefully we can learn one or two things from here. Yeah, so given a string S, we have to return the longest palindromic string in a straightforward question. A palindrome is a word that is the same from the front or from the back. So for example, Anna is a palindrome. Is a palindrome. So from the example here, if we are given BABAD and the output should be BAB because that's the longest possible. And ABA is also available, but since it's the same length, we could just pick anyone. It doesn't really matter. So let's just look at how we want to go about this. So if we are given S to be uh, BABAD and we have to find the palindromic. So for one coming to my mind now is we can start from B and then we know B has, we can have B, can have BA, can have BAB. I'm trying to form all possible substrings starting from B, BABAD. We can go to the next one, which is the next character, which is A. So from A, we have A, we have AB, we have ABA, we have ABAD. We can go to the next letter, which is B, B, BA, BAD. We can go to A, A, and AD, and then the last would be D, and that would be D. And then after we've gotten the list, we could now be checking, okay, so through this list, what items here are palindromic, and then which is the longest. So this is palindromic, this is palindromic, this is also palindromic. Uh, these single letters are definitely palindromic. So those are the palindromic, and then we see that the longest are this and this. So any of them will do. Either BAB or ABA will do. So basically, that is just the one approach we could use. So let's look at the time complexity for this. This will be to get this whole list, we need to do a double for loop. We need a loop to start from here, B, and when we're at B, we want to go through all the other items BA, BAB, BAB, and up to D. We go to A again. So one loop is going this direction and the other loop is going this direction. So that's O of n square already. But also, when we have done this, we also want to check if it is a palindrome. And to check if it's a palindrome, I will need to go through the item and see if the string is the same from this direction and from the other direction. So that's at best, that's an O of n algorithm. So putting it together is going to be an O of n cubed algorithm since this will be within the same for loop. So let's see, this is an approach which could work, but I feel there should be a better approach. And I think looking at this also, and let me just get this. Let me just get this so that we can. Okay. So now, so given that we have this now, uh, and we have S is equals to B A B A D. So how can we go about this again? Well, looking at this, first off, is that we could decide that, okay, if I start from B, I know that a palindrome. So if I have a palindrome, let's say Hannah, this is a palindrome. I know that for each of them, they have a starting point. So maybe I use let me imagine this was a single N. So let's just work with HANAH. Imagine this was how Anna is spelled. Now, how we know this, we can know this is a palindrome because at the center, when you go from the center to the left and to the right, they are the same. So if the center is N, then it means that at this point I have AH, and in this direction also I have AH. So that is another approach I could use. And so let's see how that will look like. So if I have Anna, I want to start from H. So when I'm at H, I want to go backwards and forward. So at H, I see I have already passed the limit. So this is beyond my bounds already. So I don't need to go forward with that. And so, but at this point, I know that the longest palindrome I have is H. So when I go to the next, which is A, when I start from A, if I go forward and backwards, I have H and N. Now I know A is palindromic, but H and N will not be palindromic because H and N are not the same thing. They are not the same character. So I stop there. I know that my palindrome is still maximum of 1. I could go to the next letter, which is N. And from N, if I go forward and backwards, I have A. Okay, so this is palindromic. So I could go forward and backward again. And this is still palindromic. So I could go forward and backward again. But at this point, I'm out of bounds already. So what I have as a palindrome is HANA, and that will be 5. So I now know that at this point my maximum is 5, which is Anna. I could go to the next letter, which is A, and at A, the second A, I have H here and I have N here. So definitely this is not palindromic. I could go to the next one. H is a palindrome, but when I go this and this way, this is already out of bounds and this is A. So I know that this cannot work. So at the end of the day, I can find that my palindrome is at this point. Now, this is correct. But let's take, for example, we have a scenario like Anna. And let's try this approach and see. So if I start from H, just similar when we start from H, going backward and going forward, this out of bounds. We go to A, going forward and backwards. This is going backwards, we have H, going forward, we have N. So this is not palindromic. We go to the next N. N is palindromic, but when we have A and N here, it's also not palindromic. We go to the next N, and at this point we have N here. At this point we have A here. So this is also not palindromic. We go to the next A. Forward is H. Backward we have N. This is not palindromic. And finally we go to H and we are out of bounds. So this will come out with the fact and tell us that with the longest palindrome is just the first H, for example, or any character could be the answer here because there is no palindrome more than one character. So that is what this algorithm will come up with. But that is not correct because we know for certain this is a palindrome. And why is the algorithm not going to tell us it's palindrome? Is because at the center of these two are the focus points. Unlike for Anna, when it is a single N, the center of it is just one N. But when we have Anna with a double N, the center is 2 letters. So it means there are 2 scenarios here. When we have a letter as the center, or when we have 2 letters at the center. So even if I have something like this, let's say HANA, okay, yes, so we have this, and I say, okay, these 3 are center. It's as good as also saying that if I try to make it more than 2 and I say, okay, what if I say 3 are at the center? That's also correct, but that's as good as saying 1 is at the center also, because on the left and on the right of it, we have A. So it means the 2 scenarios are when we have 1 at the center and when we have 2 at the center. So, but basically the same approach, because if we are to go ahead with this now, we'll see that, and let me just get some space here. So when we have Anna here, so So if we take it 2 by 2 now, we say HA. And of course, H and A are not palindromic, so there's no point going ahead. So I can go to pick the next two, which is AN, because they are not same, so there's no point going ahead. I go to the next NN. Okay, so this is palindromic. So what I now do is I move this and I move this. So this is A here, this is A here. This is also palindromic, so I will move this a step further and I'll move this a step backwards, and this is also palindromic. So when I now move it, I'm out of bounds. When I move it, I'm out of bounds, and I know that. So the longest I have here is Anna, and that's how we get an answer. If we continue, so we continue with NA, continue, but this is not palindromic. AH is not palindromic. So, and we know, so with this we are able to get that Anna with the double N is a palindromic word. So let's put this and let's see how this the complexity for this. So we are going through, so for each of them, so for example, let me just pick Anna. For each of them, we are going from this end to the other end, and for each of these, so that is an O of N definitely. For each of these that we keep going in this direction, we are going to be going. So for example, at H, when we're at H, we are going left and right, and it's possible we go the whole width. So we are also going an O of N again. So it means that this gives us an O of N square algorithm, which is better than the brute force we were trying to use, we talked about initially. So let's see how this comes out in the code. So here we see that we know that for fact that we will need, so let's go back to the algorithm, to the description we had, look at it again. So we need to track, okay, my center, where my center point is. Okay, and so let's see how we can go about this. So let me just create a variable and just say, call it left, and let me just call it left and just give it 0. So why I'm doing this is that I want to keep track of where the longest where the longest word starts from and ends. So maybe I call it max left, and sorry, max left, and I call this max right. Yes. So what we could now do is, we know that we have to go in our for loop. We are starting from the first point all the way to the length. Now, so we know that for each of these, I am going to go, so I will have this scenario where I will be going from the same point, and I will have a scenario where I will be going from the character beside each other. The center point is going to be 2 characters. The center point is 1 character, so I, and then the center point for the second scenario is where we have two characters beside each other, standing beside each other. So let's see how we go with this. So first off, for this, I know that I will need to, so I know that I will, so while I know that my left is within bounds, just to make sure that I am within bounds, and the right is less than the S, just to make sure I am between bounds. We always speak of the bounds. So for example, when we are illustrating here, we said the bounds. So if it has not gone beyond the bounds on this side, so the right, would one pushing on the right has not gone beyond its bounds, and the one pushing on the left also has not gone beyond its bounds. So that's basically what we're trying to achieve with this. So the left is not is greater than or equal to 0. That means it's within the bounds, and the right is always supposed to be less than the length. That's also within the bounds. Now we know that what we want to keep going for as far as what is on the left, or what was on the left, is equals to what is on the right. That's as far as we want to continue. So we want to keep going as long as what is on the left is the same as what is on the right. So, and you know what we do when it is the same, we want to go to the left, you want to go backwards, on the right, you want to go forward. So that is, you're expanding it, you're making it, we're enlarging our scope of check for the palindrome. So that's basically what we're doing here. And you know, so for example now, when we have gone through, so for example, let's use an example here. So if we have this, let's say we have this here, B A B, and then let's just say we have Z. Let's just put something like this just for to have it like this. So you know, let's assume we are at the focal point A. You know, when we go this direction and we go this direction, we see this is a palindrome. So what we do is we now expand it, we now find it is not a palindrome. So you know, currently we are here, even though we have found it's not palindrome. What we have to do is we want to reference it back so that it comes back to BAP. We know that BAP, the last reference point where we had the palindrome, was BAP. So we have to go back to that. So basically it means that when it has found a place where it can, I know that it means, so basically what this is doing is I'm going back. So on the left side I'm coming back forward because I know that was the last point that I had a palindrome, and on the right I'm coming back one step backward because I know that was the last point I also had a palindrome. So basically that is what I will need. So that's basically what I will just need here. So but what I will just do, because it's the same logic I will use for both of these, let me just extract that into a function. So that will just give us, let me have a tuple. Let me just have it. And so let's just call it find palindrome. And I will need my string, I will need the left, and I will need the right. I think, so let's just paste this here and see. So yes, so I have, so on the left side I'm checking, okay, so at the end of the day what we want to do is we want to return our answer. So just to format it properly. So we just want to return our left and our right as a tuple. So what I could just do here is that I know that left 1, right 1, and I know that once I call the find palindrome start, so for the string, and you know, because it's at the same point, so that's going to be, I'm starting from the same point. The left and the right are at the same point when the center is just one character. But you know, when the center is 2 characters, that will be something like that will be find palindrome and then the character beside it. That's what I'm trying to achieve with this now. So when when we are checking for when the center is just 1 character or when our center is 2 characters, so we have to check for these 2 possibilities, and we can check for them simultaneously. So we check for the first one and we check if the pair, if it is good paired up with a neighbor, it will be able to get a palindrome. So basically that's just what we want to do. But after all of this, we just want to check. Oh, sorry. We want to check. How do I get this? Okay. So we want to check and find the maximum, because that's what we are actually looking forward to. So we want to check our max left. If we know that at whatever point we check that the width, the distance between my left and right, the longest one we have the highest distance between the left and the right. So basically I'll be comparing it with what I have as my max left and max right. So all I could just say, if the max right minus the max left, if it is not up to what I have in the right one So basically, what I'm saying is, so for example, we are saying that if we don't want to replace the maximum, if the palindrome we are having now is not up to it. So for example, if we look at our example here, imagine we had Anna. Imagine we had Anna here. Imagine we had Anna here, and we start from the front. We have started from this point, and we move to this. Let's say for whatever reason we had, okay, so let's say we had Anna, and then we have Fab here, something like this. Initially we will have already found a place where we had a palindrome with 6 characters. Now, when we come to this point and we start, we find a palindrome with 3 characters here. Although this is a palindrome, we do not want to, we know that that is not going to be our answer, because then we found a palindrome with a longer length previously, which was 6. So that is basically what we're supposed to. We're saying the max left for here will have been 0, the max right for here will have been 5. We're now saying, okay, but for this, the max length here will have been 6, the max left will have been 6, and this will have been 8. So the difference between this will be 5, the difference between this will be 2. So definitely we know that this length is more than this. So the only time we want to replace it is when what we are the palindrome we are seeing is actually longer than what is in our maximum. And so that's what we are. So once we have found it longer, so all we can just say the right is the right, and the max left is what we have on the left. And we will do the same also for the second one, where we say the right 2, and then we can just basically the same thing. This can also be abstracted into, we just abstract this and make it return it. That will be cleaner. That would be preferable. Or maybe we'll do that. Let's just do that. Let's extract this, since instead of having to repeat it. So public, let's return a tuple again. Yes, let's return a tuple. I think return a tuple is fine. Is max. So we have max right, max left, right, and left. So let's have it like this, and then what we just paste it here. And so if this is the situation, we just want to return right 1 and left 1. Otherwise, we want to just return what was there before, max right, max left. So I think this will be clean, I think. So all we just need to do here is, probably for the first one, we just have to say max. So we are returning the right versus left. So max right and the max left. And we are just saying what we are putting there is max. And we just need to pass in our max right, our max left, our left 1, and our right 1. And we know that whatever is here is going to be the maximum at the end of the day. Same thing I will just do here. I'll say the max right, max left. I'll check its max. I'll say max right, max left, left 2, right 2, basically the same thing. And then we can have it here like this. So we know that after this has gone through the loop, whatever we have from our left to our right will be the maximum length. So basically what we just want to do is, we know that if we go from the left to the right, so let me just create a variable, and I could say if I start from my left, my max left, so you could use substring, that will also work. I just want to use this, and I want to go up to my max right. So and I could just say s and I return str. So basically what I'm just doing is I know this is the beginning of where the palindrome longest palindrome is, and this is the end of where my longest palindrome is. So if I start from here and keep populating my str with what is in those indexes, I know I will have my longest palindrome. So let's run this and see what we have here. Okay, so line 21, so it does not exist. Max left does not exist. Why will it say that? So sorry. I when I copied, I did not remove this. So let's try it again and see. Okay, I think max left. This was why it was. I was using a capital M here. So let's try it one more time. Okay, we are missing. So definitely, it's saying we are missing something there. Let's just look at that and see where we could be missing it. Now you know we are having, so let's go through it again. So this, our left and our right, we see that okay, this looks fine, and we're checking if it's the marks and we're putting it back there. Everything seems fine, but we don't are not seeming to, it's in a CB I plus plus. This should work, but for some reasons not work. Now what query is that? We know we're passing in the here, right, left. We're passing left, right instead of right, left. So let's just move right. So then the left. Same thing here. Passing right. Then the left. Let's try this again. See. Wait. Yes, okay. Pass. So let's submit and see what we get. Ah, and that basically is the algorithm. So we see that to solve this algorithm, we uh, solve it as O of n squared. Thank you and see you in the next. Thank you.